Okay, welcome back. This is section 3.5, which is on the equations of lines. So we're going to see a couple of different ways to write the equation of a line. And we've seen the first a couple of times already. The first is that slope-intercept form. So recall that the slope-intercept form is y equals mx plus b, where m is the slope and b is the y-coordinate of the y-intercept. So 0 comma b gives us the y-intercept. So it gives us a lot of information, and I can graph equations in this form rather quickly. So let's graph a couple of these and see how quick it can be. Okay. Say we have the line y equals 3/5 x plus 2. Get us a little graph here. Okay. So I know my intercept already happens at 2, right? So I know that I have this point, 0 comma 2. And then my slope is 3/5, which means from that point, all I need to do is go up 3 and over 5 in order to get to another point on this line. So I will. Make my graph maybe a wee bit bigger. So from this point, from the point that I drew, the intercept that I've already got graphed here, I'm going to go up 1, 2, 3, and then over 5. So 1, 2, 3, 4, 5. And I have my second point. That's all I need is those 2 points. I connect the two, and I have a straight line. And that's it. That's my graph, right? It's quick, it's easy, it's very efficient. All right, let's take a look at another. Let's say we have y equals -5/2 x and say plus 1. If I want to graph this, again I need a set of axes here, right? The x and the y axis. Okay. I have my intercept already. My y-intercept happens at 1, so I know that I have that point right there. Right? My slope is -5/2, so that means I'm going to go down because it's negative, and then to the right. I always go right, right? The negative just tells me if I'm going up or down, and then the denominator tells me how far to the right I go. So I'm going down 5 and over to the right by 2. So 1, 2, 3, 4, 5, and over 2, and I have my other point. Once again, once I have those 2 points, I just throw a line between the two and I have my graph. There it is. Extend it with an arrow because it goes on forever, and I'm done. That's it. Let's look at one more of those. I should probably stop erasing my axes. That's what takes the longest to draw here, but that's all right. Let's say that I don't have it in that form, and I want to still use the slope-intercept form to graph this. So let's say that I have something in standard form. 3x plus 4y equals 12. I can solve this equation for y to put it into y equals mx plus b form. So I will. I'll subtract 3x from both sides. Isolate that y term. That leaves me with a 4y on the left equals -3x plus 12. Divide everything by 4. And I end up with y equals -3/4 x plus 3. Right? And I have it in slope-intercept form. I should be able to graph this really quickly. I'll do it to the side here on a small set here. My intercept is 3, so I have 1, 2, 3 is right there. And I go down 3 every time I go 4, so 1, 2, 3, and over 1, 2, 3, 4. Right? I always find that second point as moving away from the initial point that I drew. So starting there, moving down 3 over 4, finds me that point, extend that line forever, and that's my graph. And I'm done. Okay. Sometimes we'll have to write the equation of a line that describes some situation. So if we need to do that, let's take a look at, we might be asked this, write the equation of the line that passes through the point 0, 3 and has a slope of 1/2. Okay. So we're given 2 bits of information here. We know we go through with point 0, 3, and I now have a slope of 1/2, right? So if I have a slope of 1/2 in that equation of y equals mx plus b, m is 1/2. So I know that this is 1/2 x plus, and I need to figure out what b is, but b was given to me because I was given the point 0, 3. And the point 0 comma anything, that anything over here is the intercept. And so I have an intercept of 3. And in fact, I have the entire equation handed to me. And all I have to do is figure out the slope and the intercept of any line in order to write it in the slope-intercept form. In this case, I'm done just that quick and easy. Okay. Let's look at another one. Let's say we want to, the same question, we want to go through 0, 7, and I want to have a slope of -5/3. Again, these 2 things are handed to me. I need 2 things. I need the slope and I need an intercept. I have a slope, it's right there. I have my intercept right there. I have everything I need. So I can just write the equation is y equals -5/3 x plus 7. And I'm done. Easy, quick, bam. Okay. Sometimes though, they might ask you to write the equation of the line that goes through, say 3, 4, with a slope of 2/3. Right? Now I don't have my intercept handed to me, I have another point, right? But I know that my slope is, I don't have my intercept handed to me. I think I just said slope. I don't have my intercept handed to me, but I do have my slope handed to me. So I know that this equation is going to be y equals 2/3 x plus whatever that intercept is, that b. But I know that this equation, this b that I'm going to find, has to be valid for every xy, every solution that's on this line. That b is going to be the same value. And I have a point on this line, I have 3, 4, so I can plug that in. X is 3, y is 4, so I'll plug in 4 for y, 3 for x. And if I do that, I no longer have any variables except for this unknown value of b over here, and I can solve for that. And if I solve for that, I'm done, I have my b. So I will. This 3 cancels with that 3, so that leaves me with just a 2. That is 4 equals 2 plus b. And if I subtract 2 from both sides, 4 minus 2 is 2, and so I find that 2 is equal to b. And then to write the equation, because the question was to write the equation that describes this line, I just have to plug it in. Y equals 2/3, because that's my slope. X plus b, which is 2. And I have it. And there's my solution. Good. We saw earlier parallel lines and perpendicular lines. And parallel lines were lines that had the same slope. And we didn't do a whole lot with them, but we're going to play with those a little bit more now. So let's say that we want to write the equation. The question is this: write the equation of the line that is, in this case, we want it to be parallel to, let me write this point first. It goes, it'll be easier to work with it. Let's say it goes through a point, 4, 2, and is parallel to 2x minus 3y equals 5. Okay. Now if I wanted to be parallel to this line, the only thing that this line helps me know is the slope, if I can figure out the slope from this line. So I want to find that. I want to solve this for y. So I will. I'll subtract 2x from both sides. That leaves me with negative 3y is equal to negative 2x plus 5. And if I divide everything by negative 3, that leaves me with y equals a negative and a negative cancel, but I have 2/3 x, and then minus 5/3. But again, if I want to be parallel to this line, I have the same slope, but I don't necessarily have the same intercept. But that's what I wanted from that line, is that slope. So I know it's a slope of 2/3. And then all I have to do is say my line is going to look like this: y equals 2/3 x plus b. And I have a point, this 4, 2, that I can plug into my x and y. So I'll do that to solve for b. So y is 2. Remember, the first letter here is y, but it's the second letter in your point. Don't get those mixed up. 2 equals 2/3 times x, which is 4, plus b. So then, there's not a whole lot of simplification here. I can't simplify the 4 with the 3, so that just becomes 8/3. So 2 equals 8/3 plus b. And so I'll subtract 8/3 from both sides. Alright. I'm going to write this, I'm kind of running out of room here, but I'm going to change this 2 right here. It's still a 2, but I want it to be 6/3. Because 6/3 is also 2. And if I take 6/3 minus 8/3, I get negative 2/3. So I get b equals negative 2/3. Okay. And I have it. I'm going to erase a little bit of the question here so that I can write this solution. Just right here. The equation is y equals my m, which is 2/3. X plus b, which is negative 2/3, so this is just minus 2/3. And that's my solution. Good. All right, and then let's look at one last problem, and that is one that is perpendicular. I'm going to not write the full question. The question is, write the equation of the line that satisfies these two things. The first thing is I want it to go through the point 3, negative 2. and I want it to be perpendicular to the equation 3x plus 2y equals 21. Now again, the only bit of information I want from this line is its slope. Once I have its slope, I don't care about the rest of the line. That's all I care about is that slope. So I'm going to go and solve for y. Well, minus 3x from both sides leaves me with just 2y equals negative 3x plus 21. Divide everything by 2. Leaves me with y equals negative 3 halves x plus 21 halves, but again, this last number over here, it doesn't matter. It doesn't even matter what that is. The only thing that I want out of this line is the slope, and the slope is negative 3 halves. Okay? And that's it. That's it for this line, right? Once I've got that, I can kind of simplify this entire question. I still wanted to go through 3, negative 2, but to be perpendicular to all of this, that means that the slope I want for my line is the negative reciprocal of this. So that is to say, my slope, m, for this line that I'm creating is 2 over 3. The rest of this information is now irrelevant. I've used it all just to get that. M is equal to negative 2 over 3. That's all I want from it. Now I have to go through this point, and I have to have that slope. And so I can start with y equals 2/3 x plus b, and replace that x and y with my x and y here. So that is negative 2 equals 2/3 times x, which is 3, plus b. The 3's cancel out here, so I get negative 2 equals 2 plus b, and therefore minusing 2 from both sides, I have b is negative 4. And I have my 2 bits of information I need for my solution. I just need to write my solution now. That solution is y equals 2/3 x plus b, which is minus 4. So minus 4, and that's that. All right, thank you, and I will see you guys next time for 3.6.